In this video, we're going to take a look at randomized block experiments. In the bulletins, you can see what we're going to cover in each topic when it comes to this very useful strategy. So randomized block experiments are technically just experiments that pertain to a specific sample size or a certain population that consists of different groups of subjects. These different groups of subjects are randomly assigned to in each individual block. This can be ranging from anywhere between age to gender to race, so on and so forth. And each one of these blocks undergoes or is subjected to undergo various different types of treatments. This entire experiment's purpose is to basically increase the efficiency of an experiment. Increasing this efficiency is done by accounting for not only the variation of a sample size but also the nuisance factors, which are irrelevant data we might take into account during our experiment and can skew or hinder our results slightly. Alright, here we have an engineering-related example of a randomized block experiment in the form of a tree diagram I have made. At the top you can see the sample size, which in this case is going to be different types of materials that are used to design a space shuttle that is taking off. These different types of materials are going to be sorted into blocks A, B, and C that are all going to be undergone by a different type of random experiment. This experiment is going to be exposing these materials to different conditions. These treatments are going to be different types of temperatures. At the end of this experiment, you can analyze each different type of materials results to different types of temperatures and determine which material is going to be best for your shuttle. It's also good to note that the nuisance factors are listed at the top to distinguish between the variants of the randomized block experiment. After you are done with the experiment, you can separate your data and results into a data and an ANOVA table. Neither of these tables are going to have numerical values, but as you can see in the data table, you're separated into your block column, ending with your block average, and your treatment column, ending with your treatment average. This is just going to help you figure out your variance that comes along with this randomized block experiment. In the ANOVA table, it's separated merely into source of variation, your degrees of freedom, your sum of squares, your mean square, and probably the most important column, which is your test statistic. This test statistic is going to help you locate your p-values of both the blocks and the treatments, which is also going to help you establish a variance. So there you have it. I hope this video has increased your knowledge on randomized block experiments and shown their importance not only in our engineering careers, but our everyday life.